Hello, I am Cesar. I am together with my friends, developers of the Keppe Motor. Here is Roberto and Alexander Fascari. And what we have here is a fan, domestic fan running with a Keppe motor. And this Keppe motor is running this fan with a blade for a 50-watt equivalent fan, conventional motor. So this blade is spinning at 676, 680 RPM, around that. This is the spin, the rotation of a 50-watt fan, equivalent fan, right? And so we are here in São Paulo with a very cloudy day, as you can see, and we are going to demonstrate the consumption of the motor. The motor is consuming now, this is ampere meter, okay? Let's zero it and measure it here. The motor is consuming 0.5 amps with 12.1 volts from the battery, right? This means this motor is consuming 6 watts to run a 50-watt motor, equivalent motor, right? So this makes already a gain of more than 80% energy. And what we have here is a solar panel, right? It's a 20-watt solar panel. And as you can see, the sky here in São Paulo is very cloudy today, which means we do not have direct light onto the solar panel. And I'm going, Alex, can you please plug in the solar panel to see the result on the motor? Now with the solar panel, we can measure again what is coming out of the battery. That consumption diminished to 0.3 amps, which means the motor, Keppe motor, now is consuming 12 times 0.2, 0.3, 2.5 to 3 watts only, with no sun at all. Right, with no sun at all. This is very important to emphasize. But now we are going to wait for the clouds to open a little bit, and we are going to show what happens to this system, solar panel, battery, and the Keppe motor. We are down here in São Paulo, a city in Brazil, in the very limit of the parallel 23, which means we are in the middle of the tropical and subtropical climate. So this is not the best area in the planet to collect the solar energy. But we are going to demonstrate how a very small solar panel, with 20-watt solar panel, we can run in a cloudy day a 50-watt motor, a 50-watt fan, with a Keppe motor consuming practically no energy at all, and the battery being fed by the solar panel as well. As the sun rises, this negative number increases. 0.2. You can see here the sun is beginning to appear. 0.3, 0.4, 0.5, 0.6, 7. This means that the battery is recharging very, very fast, as you can see here. 12.6, look, the battery is receiving 0.8 amps and increasing its voltage. And the motor is still working. Look here, 71, 72, and going up and up, more and more. With just few seconds of sunlight, you can recharge the battery and keep an equivalent 50-watt motor working non-stop regime. Now the sky is clearing up a little, and the battery is receiving, let's see, the battery is receiving 1 amp, and the voltage is increasing fast. You can see with just 1 minute of sun, the battery increases very fast and the motor doesn't stop. This means that the motor can be used for irrigation in semi-desert areas like the northern region of Brazil. A battery like this can move a motor with a 150 water pump and constantly irrigate a specific area with almost zero cost. Only the cost of the solar cell and a battery. The battery can charge during the day and run the motor at night till the next day, when just few minutes of direct sun are enough to recharge it again. Okay, now this is the original fan. As you can see here, they have the same blade. And now we are using an inverter there. This inverter is connected to the solar panel and the battery. So I would like you to pay attention on how it will be the difference in consumption between the two motors. I'll put it to run now. Okay, this is the first speed. First speed is spinning at 530. 540 and 40 RPM, something around that, okay? And the consumption, look at the battery, how the battery drops quickly. Very quickly the battery drops. And
the consumption is 47 watts.
Consumption is 47 watts to run the motor at 500. Like I said, no, look, the spin is dropping very fast now. 480, 477, 72, 70, which means this motor is consuming the battery extremely fast.
The battery and the solar panel?
And the solar panel cannot overcome the consumption of the battery. Now, if I increase the velocity here for the second velocity, which is supposed to be 850, now it's decreasing to 670 RPM with the consumption of
47 watts, because it's the maximum you can supply.
Yeah, the maximum it can supply is that. You see, so the solar panel plus the battery cannot keep the motor spinning with a regular fan. Much differently from what you observe with the Keppe motor.